Let's kick this one off with another one of my favorite quotes. The original concept came from Harper Reed. It goes like this: "It's not about being smart. It's about being smarter than the attacker." And that's what being an ethical hacker is really all about, is understanding what the attacker is going to do and just outthink them. Now, our learnings kind of align with some life teachings that my kids have heard me say hundreds of times to them. I wouldn't be surprised if they put it on my gravestone when I'm gone. I always ask them, did you see the big picture? Or at least make sure that you can see the big picture when looking at any concept or any of your trials or anything that's important in life. It's important to understand that picture about what we're dealing with. And when it comes to hacking mobile platforms, it's exactly what we need to do, is look at the big picture. Don't focus in on the small things. Let's start off by looking at the Android security environment. To understand any type of security, you need to know the architecture that lies underneath the platform. It'll show you where the holes are in a device. Looks pretty ominous, doesn't it? Let's deep dive this. Android security is layered like an onion. That's a quote from a famous ogre. Like Windows, Mac OS, and others, Android has its own kernel, or I should say, it's based off of Linux, that kernel. Android is used because, let's face it, it's stable. It has a proven driver set. Linux kernel itself creates an interface between the hardware that may be installed on the device, be it display, camera on the device, USB ports, networking ports, keypad on the screen, Bluetooth, Wi-Fi, sound, power features. All of these devices are supported directly to the operating system via this layer of the architecture. Now, the top layer of the Android operating system is where all the Android system programs reside. Any program developed should actually be able to fit into this layer. The dialer, email, calendar, camera, SMS messaging, browsers, contact managers. Again, the list goes on and on. They're typically pre-installed as a standard app on every Android device. Java is the most commonly used program language. You know what? Let's look at the library layer. This layer has some built-in libraries. Things like the Surface Manager. This is simply there to compose windows that you see on your screen. There's also the OpenGL and the GL Kit, or Graphics Library Kit. These oversee both the 2D and 3D displays. What's cool about this infrastructure is that the application can switch between 2D and 3D almost seamlessly. We also have the Media Framework. This supports the playback and recording of media. For example, our codecs are built into this framework, like MP3, so that you can play a song. When you power on a brand new phone and you can take a picture and look at it immediately, it's because it's in a JPEG format. And that Media Framework includes that codecs. Some of us can remember the day when we would download a particular file format and we had to go off and find the application to actually run it. There's also FreeType. This component is there to render out, our fonts. You probably saw that one coming. And you can go through and change the fonts that are being displayed throughout the system, including the size, the type, or the characteristic of that font. Some applications will also pull on this FreeType so that you can change the font within the application itself. Then there's OpenSSL. This gives us security when we're communicating with other devices. There's also SQLite. It's a database engine. Uh-oh. Did you catch on? SQL. Wonder what kind of attack you've learned about in this series you could throw at this. Because it's a database engine, it can create vulnerabilities in our devices. The same type of vulnerabilities that we see in a standard SQL database server. You figure out what I was talking about? Yeah, injection attacks. And then there's also the WebKit. This is an open browser. It's the same engine that Apple's Safari uses. We then have what they refer to as the Java API framework. We have core libraries at this level. It's simply a runtime layer that includes a set of Java libraries, including things like the Delvik VM. This is an open source software that was named after a fishing village in Iceland, where the creator's ancestors hailed from. It's basically a virtual machine, and it's been streamlined for mobile devices so that there can be multiple virtual machines running to support multiple apps. That's how we get the sandbox. In the Android world, we sandbox each of our apps. Remember me talking about that earlier? It has a low memory requirement, and it relies on the underlying OS for process isolation, memory management, and thread support. We also have the framework layer. This is where we see the core applications that come with our devices. For example, T-Mobile may load some default apps that are proprietary to their environment, like TouchWiz. It's an interface that they load on top of Android. Basically, it's what creates the GUI interface, or enhances the GUI face of Android. There's also the Activity Manager. It simply manages the life cycle of applications. This includes the starting of an application and running of it. It also has a pause state, so if the application is paused, when we switch to a different app, everything is okay. There's a stop state as well, so if it hasn't been used in a while. And there's also a destroy state, which removes things out of the resources. Then the Activity Manager decides that there's no more use for that activity, and we regain those resources to be used for other apps. There's also the Window Manager. This is what we see on the screen itself, so there's no component that we can actually manage. There's the Package Manager. This oversees or keeps track of the applications that we've installed, especially when it comes to updates or how to uninstall a particular application. There's the Telephony Manager. This oversees and manages our phone calls. I mentioned this before. When we open up a contact, we see their phone number, we click on it. You need to fire off and dial it, right? Well, the application is calling the Telephony Manager. There's the Resource Manager. Yeah, you don't get any bonus points if you can figure out what this one does. Yeah, it's for managing our resources that the applications are using. Then there's the Content Providers. This manages the data shared between applications so that we get that seamless feeling in the environment itself. A great example of this is a couple of our default content providers include a call log, which provides our missing calls and call details and time of calls. When you start typing things in and the user dictionary may not recognize the word, but you know it's correct, and you hit the "this is a correct spelling" option. It also comes into play when we install things like Facebook. When you click on a photo button, you might pull up the content provider into the Photoshop gallery so that you can share photos via a Facebook application. There's also the Location Manager. This is a framework that's used by, your GPS, and also the cell towers to help determine where somebody's located. Great example of this is I can pull up via an application and see where my kids are located. They don't have to have their GPS on. It does a triangulation through cell towers. There's also the View System. This is simply what it sounds like. It displays views that we have of applications, different windows. It does a lot of communicating through the Windows Manager. And finally, we have the Notification Manager. This application just notifies us, when we miss a call or a text message. Okay, was that hard? It doesn't look that bad after you have it explained to you. Tell you what, now let's talk about rooting. Go Dale! No, not that kind.